Hello, welcome back to the shop. This is Iron Horse Machinery. My name is Greg. Today I just wanted to do a little follow-up to the last couple videos where I was talking about strength of materials and elastic behavior in metals, steel, other kinds of materials that we use in the shop. And the point I wanted to make is that even for a very stiff material like steel, the fact that it's elastic means that no matter how little force you put on it or how little stress you apply, it's still going to deform a little bit. And the stiffer and stronger a machine is, the less, or a part is, the less it's going to deform. But it will always deform a little bit. If it's a flexible machine or a flexible part, it will deform a lot. But even a machine that is intended to be very stiff will still deflect a little bit. And I'll illustrate that on my drill press here, just as a way to explain that. So here I am at my drill press. I've got it set up with a dial indicator that's mounted to the column at the back, or the magnetic base is attached to the column at the back, and the indicator is attached to part of the casting on the head. So what it's measuring is any motion, any deformation that involves the column and the head flexing in some way. So what I've got down below is a part, just a pulley that's in there, so I can push against it. And what I want to illustrate is that if you watch the needle here, now I'm not putting any load on it, but now if I push with my thumb, that needle's starting to move. Maybe a little hard to see from the camera angle, but there it is. I push with my thumb, it moved down. I moved down, there it was 2/1000ths, just with the pressure on my thumb. So 2/1000ths of an inch. If I push more, I can push it harder and get 4/1000ths of an inch. So that's indicating that even on an old, well-built machine like this is an old Delta 14-inch drill press that I restored a while back. It's pretty heavy duty compared to what you would buy today in a box store, but still it flexes. And so if you're drilling something, you have a drill bit in there and you're pushing down to drill through something, that head is flexing, the table is flexing, the part is flexing, lots of things are moving. And the stiffer the machine is, the better it is, because usually that movement is undesirable. But it doesn't matter how big and how stiff your machine is, there's always movement there. Even if this was a big, heavy-duty industrial kind of drilling machine or a milling machine or anything, it may be moving a lot less, but it is still moving. You may need a very sensitive indicator to see that it's moving, but it is still moving. You can't escape that. So you always have to be aware of that movement, plan for it, anticipate what it might do either to the part or to the safety of the setup, and just be aware of it. That's the main thing. You can't get rid of it. You can only deal with it. That same flexibility in a milling machine is what causes a slight offset due to the radial cutting forces on a bit, like an end mill or a face mill or something. It pushes everything off a little bit. It's what allows for the machine to chatter, or the cutter to chatter, that movement. So that movement is always there. And it's just one of those things that, a lot of people, especially when they're first getting into this, they think, oh, well, this is very stiff, it's not moving at all. Well, it is moving, and you have to be aware of it and account for it in various ways. So that's it. I just wanted to illustrate that a little bit, and I hope that was helpful to some people. Thanks.